Hello and welcome to a new episode of the Computomics podcast. Our guest today is Research Director of South African company Starke Ayres, Glendon Ascuff. Welcome, Glendon.
Thanks, Anna. Great to be here today.
Well, we're very glad to have you. Glendon, we like to start with a little icebreaker out of left field in this podcast. And I was wondering, what's the last thing you read, saw, or heard that inspired you?
I'm busy reading a book by Bill Bryson called At Home, and it's kind of gives the history of all the different rooms in the home, how lighting came into being, how kitchen appliances were invented and adopted mainly throughout Europe and the US. And so that's really inspired me to see how far just domestic life has evolved and progressed in the last 150, 200 years. It really has been quite quick. You look at humanity over thousands and thousands of years. So that's inspired me to see some of the terrible inventions, and how terrible inventors really were, and yet many successes as well. So yeah, looking at home in a whole different light, I guess.
That's interesting. I'm sure we'll have one or two points where we can relate back to that, even though it's not your actual core thing that you do in your professional life. That, as I've briefly mentioned in the introduction, is Starke Ayres, a company that is, as far as I know, the biggest independent veg breeding company in Africa. Is that correct?
I think so, yeah. Certainly in South Africa, but probably in terms of vegetables, probably in Africa as well, yeah.
Can you tell us a little bit about the company? It was founded in 1877, but how did that come about?
So it's a really interesting history, and I think the older I've got and the longer I've been in agriculture, the more interesting history becomes. 1877, Charles Ayres came out to South Africa from the UK, and he started a flower shop and a seed shop in Cape Town, which is in the southwest of our country. And in about 1920, he merged with Chase Starke. And so Starke Ayres, that's where the name comes from, the two kind of founding fathers, if you like. Well, they didn't found the company together initially, but certainly agricultural and seed activities since 1877, as you said. And I guess the company has developed in an interesting way. We were simply a seed merchant for the first 100-odd years. We trialed other companies' seeds locally. We see what performed well, and then we sold those on to customers. And so over the years, we've sold quite a large amount of seed into the retail sector. And so the hobby market, home gardeners, grocery stores, small packets of seed and vegetables, flowers, etc., herbs, grass, kind of everything in the retail space. But then also in the mid-80s, when the current shareholding family bought the company, we kind of began our own breeding activities. And so really only been doing our own breeding for the last 30, 35 years or so. And so our kind of our product mix is retail lines, our own breeding varieties, still many varieties from other companies that we're distributing, as well as open pollinated lines throughout different parts of Africa. So it's kind of a mixture of everything kind of together. And it's great to be part of a family-owned company and being able to kind of take it into the future. So it's a great company. But I suppose most people probably love the company that we're in. Maybe it's just
Ideally, I feel those that actually enjoy their job usually do. If you don't, then you're probably kind of looking to go elsewhere. That isn't the case for you. You have a background in botany, correct?
Yep, I do indeed. Yeah.
So what exactly inspired you to join Starke Ayres, and what's your role there?
Yes, up until the end of high school, I wanted to do accounting, become a chartered accountant and make loads of money. But I think in the late 90s, as I was finishing up high school, genetic engineering was kind of a hot topic, and Dolly the sheep and all of those kinds of things were on the syllabus, on the radar at high school. And so I ended up changing my mind right in my last year at high school and studied science and botany and genetics at university. And in my last 2 years at university, I received a bursary from Starke Ayres, and I had to work that back when I finished my PhD and postdoc. And so able to have a couple of years of working back, and in that process realizing, man, I love vegetables, I love agriculture, I love genetics, I love research. and kind of made the role permanent after I had worked back my bursary with them. Yeah.
And I don't know which podcast it was that you said this in, but you're quoted in my briefing as saying, "For me, the real joy is discovering how plants work." Is that the correct quote?
Yeah, I think so.
Or does that sound like you?
Yeah, I think being able to see like really simple Mendelian genetics that you can learn in high school applied in a breeding program, and they behave just as Mendel kind of predicted, 150 years ago. That is so cool to see that happening and playing out obviously more complex traits on a day-to-day basis, and then being able to interact with our breeders or our pathologist or our biotech team, and to see them realize, hang on, it's complex and yet it's understandable. And for the traits we're working with, able to predict them and see those traits perform in subsequent generations, it just like completes the picture, if that makes sense.
Yeah, totally. Are there specific traits that you're focusing on in your work at Starke Ayres?
Yeah, I think with most veg breeding, pathology are the dominant kind of traits that are easily trackable. And so for our squash breeding, our tomato breeding, our bean breeding, etc., sweet corn breeding, very much the focus is on disease resistance for diseases that we have locally. But as we're selling into Africa and other parts of the world, trying to figure out how do the genes we have for resistance here, how do they perform against different isolates of the same disease or against related viruses or bacteria in other parts of the world? So it's the complexity of what we're doing increases as we kind of expand on a regional and kind of global scale.
Mm-hmm. We have a little bit of time. Can you give an example of one disease that has different varieties, if you will, or varieties that you breed for different kind of phases of a certain disease within Africa?
Yeah. So tomato bacterial wilt, the pathogen name has changed multiple times. Pathologists, I think, want to keep their job security, and so keep changing the pathogen name. So I used to know it as Ralstonia, but I think it's now 2 or 3 different species with the most recent kind of update. But it's a soil-borne pathogen, widespread in tropical and subtropical areas, especially high temperatures in the soil. And I think like many root pathogens, the resistance is pretty complex. It's quantitative. There are a few major genes that can be tracked using markers. But within South Africa, we've been breeding for resistance to bacterial wilt for a good 35 years. And so the resistance that we have in our germplasm in South Africa performs really, really well. We've got really solid, stable resistance. As we've moved into other parts of Africa, we've got subsidiary companies in Kenya, Mozambique, Namibia, Zambia. We've seen our varieties perform well in some cases, but not always that well. As we've sent trials to other parts of the world, for example, Brazil, the situation is very different, and they have different phyla types, different strains and isolates of the pathogen that are far more varied than what we have here in South Africa. So our varieties haven't always performed as well as we'd hoped they would in, for example, let's say Brazil or Kenya. And so that's a challenge, trying to figure out which of our resistant sources is more resistant against different phyla types or different isolates. And it's not always easy to predict, unfortunately. As much as we read the scientific literature, having trials on the ground really is the ultimate kind of proof and conclusion.
Mm-hmm. I mean, the natural follow-up is, how do you go about addressing that challenge?
Well, screen your material widely as you can and have trials in the location, in the target environment, so that you can see how they perform and make sure you've got the right kind of controls and checks in the same trial. Otherwise, you're kind of guessing how your own varieties are performing. And so we don't have any subsidiary companies out in South America. And so we're having to partner with different collaborators and different companies and agents that we work with out there. And so that's also key, having good relationships and ongoing collaborations that are strong, and we're able to rely on them to do some of the screening activities for us.
This would be screening on site, so with the trials that are going on there.
Yeah, exactly. Yeah.
Well, one collaboration, I'm obviously biased in the Computomics podcast, but one collaboration that's been going on since November 2024 is your collab with Computomics. Can you tell us a little bit, or our audience a little bit about that?
Yeah, sure. So I guess we've been interested in machine learning and predictive models for all different types of traits and for our different breeding programs. And I guess being a small company, we don't always have access to really high-end research facilities or big money through great research projects compared to, let's say, the multinationals. But the journey with Computomics, I think, has just started, and it's very much ongoing. And so we decided to take our sweet corn program and looking at the existing data that we did have on several defined phenotypic traits, see if we could build a predictive model to help us better predict hybrid performance in selected environments. So firstly, within South Africa, and the aim as we move forward is to be able to predict how we could combine different parent lines to predict high performing hybrids in other locations where we're wanting to, not able to get lots of trials in, but obviously we have the GPS data, the weather data for those locations, and wanting to make the process more efficient of being able to place trials not on a shotgun approach, but using some data and some good decisions from that data to shortcut some of the processes in getting hybrids to market quicker.
Mm-hmm. I mean, it's a bit martial, but it works as a metaphor. So if you have the shotgun approach, that's kind of more or less what you have to do with the traditional approach. Now with this collab with machine learning, you can go for a more, I guess, a sniper approach.
Well, exactly. And we don't have breeding locations or trial locations in all the key markets for sweet corn in this case, the current collaboration, but for any of our crops. And so the more ways that we can find to improve our chance of success, those are always good. And there's so many learnings on the way, I guess. That's
like what?
Normally sorry?
Like what, for example? Because you said, I mean, obviously you're in the early stages of this new kind of approach within your company, but do you already have some of those learnings along the way?
Yeah, definitely. I think the most important one that there's several. The breeder that is busy doing the collaboration with Computomics, she took over from the previous breeder, and there was the previous breeder perhaps organized things in his own way on Excel, and she had quite a job to move those very manual kind of spreadsheets all the way over to our breeding software that we're using for all of our breeding programs. So for her, there was lots of effort in just getting the data in the right format. And once that had been done, she was able to collect the data very quickly. But data quality, data integrity, and measuring the right traits is obviously very important. Now, I remember the first kind of few months of interacting with the breeder and back and forth with Computomics, and then realizing, this is what we need to do. And it kind of clarified things. We could simplify the data that we were giving back to Computomics for the machine learning model. So that was one for sure, the data quality. As we've looked at the interim reports from Computomics, the making sure we have a good spread of data for the trait that we're trying to predict. Often breeders will walk down a line of plants and ignore 80% of them simply because one or two traits don't meet the optimum criteria. But because of that, they don't record, let's say, the plant height or the ear height or the number of kernels on around the rows, etc. And so if you've got a very skewed data, your ability to predict outside that range is very limited. And so making sure we have a good range of trait data either side of the optimum is really essential for building a good model.
Very interesting. Yeah, I can see how, if you had like more of a traditional approach, or like you're used to only recording certain types that used to be the only relevant ones for the older approach, how that also necessitates almost like a mindset change or relearning of processes.
Yeah. And I think breeders do that naturally because they want to be efficient. If they know a plant is never going to make it through a round of selection to the next generation, why go through the effort to record all the different characteristics of that phenotype when they're not going to select it? So I totally get the mindset why they walk past plot after plot. It simplifies things. It makes them more efficient. But if you're wanting to generate a good model, then you've got to kind of go back to the basic fundamentals and record kind of every aspect of the phenotype in as wide a range as possible. So yeah, it is having to change our thinking a little bit on how we go and how do we plan better trials that we can get good data for in-house use and good data for updating the model in the future.
Did you have to do any so this is a little out of left field maybe, but I'm thinking that's sometimes also hard to change these processes if you're a mid-sized company, right? Family owned, but still there's a number of people involved. How do you get those processes implemented, and how do you get people to see, hey, okay, it might seem less efficient now, but we're going to make that back up further down the line. The efficiency will come in when the machine learning comes in as a support. How do you go about that?
Yeah, great question. I think with breeding and working with scientists, breeders who are really highly qualified and experts at what they do, you can't take a top-down approach, and so you've got to interact with the breeder over a number of weeks and months and convince them slowly that this is the right approach to take. And often in that process, my idea of the right way to do things isn't the only way. And often between the two of us, we get a better way forward. So I think you can't mandate or be authoritarian in how you make changes. If the breeder is excited about the potential and has the ability to make changes, that's great. I think being a smaller company does help us to be a bit more flexible and agile. We're able to put some things on hold for a short time without affecting the bigger picture and where the breeding program's going. So I think that's a huge advantage. We're able to do that on the fly if needed. But the reality is, as you said, there are only so many people on the ground. And so if you start something new, you kind of have to cut somewhere that you're able to free up those resources of time or energy or just physical traveling between breeding locations. That has an impact. And if everything's happening in the summer at 4 different locations, there's just limitations to how much a small team of people can do. So while we can be flexible, you have to be realistic about what is actually possible by a small team.
How long is this project or this collab first phase maybe? How long are you looking to pursue that?
Yeah, well, definitely we need to do another round of phenotyping with our next summer trial. So that'll happen in the next 6 months, probably February, March. We will gather the last kind of phenotypic data for the next round. And we're really keen to see how an additional big data set will improve the model. The first round of model, we kind of gathered what data we could get at the time. And it actually was completely insufficient. And the guys at Computomics are very gracious. They said, well, we'll do what we can with what you've got, but T's and C's apply. And so they're very kind to work through the whole process, even though we didn't have sufficient data to really build as robust a model as we wanted. But seeing what they could do with the little input we gave them, we're realizing that another round of phenotyping and probably increasing the observations by about 4 or 5-fold, wanting to see what that does to the model and the accuracy of the predictions that will come out of it.
Yeah, that makes total sense. It's almost, you said it in the beginning, right? It's a totally new approach that you're trying to integrate, to innovate within your company. That's going to come with some challenges in the beginning, finding out what you need to change, and then you can go into the next kind of round, into the next stage, and see the results that'll come from that. So how do you see, this is kind of adding something new, how do you see the balance between traditional plant breeding and with modern technologies like a data-driven approach, biotech, stuff like that?
It's such a good question. I think when I joined Starke 15 years ago, only one of our programs was doing marker-assisted selection. And that was really on a handful of markers, sending samples to the US for tomato MAS. And so I think in the last 15 years, we've been able to take a very traditional breeding, multiple breeding programs and very quickly integrate high throughput SNP genotyping, marker-assisted selection, designing markers from publications. In the case of things like tomato, there's so many good public breeding programs that are publishing really good work. And so there's been some quick and easy wins on that side. But being able to employ bioinformatics staff and do sequencing of our breed lines has enabled a whole new level of designing markers specific for our own germplasm and how it performs locally. So I'm trying to answer your question by saying we've come a long way in 15 years. None of our breeders were doing marker work except one, the tomato program. Now we're tracking more than 50 traits. We're generating about 7 million data points a year through our SNP lab. So we've come quite far quite quickly. But as we read the literature and as we attend conferences, we see there's so much else happening, like genomic selection and advanced breeding technologies like gene editing, which is a bit challenging in South Africa for regulatory reasons. But we're kind of exploring each different avenue as we see benefit for a particular program and how it fits into that breeder and how they've structured their program, and to see or to ensure that it will have benefit for multiple programs if we had to integrate that into our R&D pipeline. So for us, it's difficult to take one technology that might work, let's say, for sweet corn or maize, and apply it to a different program like beans, which is a self-pollinating crop, and you don't make up hybrids at all. And so we try and look for technologies that will benefit multiple programs, but we do a pilot program on one of them at a time.
What can be inferred from what you just said is how fast you have to keep changing as well, right? Keep testing different approaches and integrate what makes sense. One thing I was wondering about, given your history as merchants of seeds as well, and your close connection that you have with farmers through your work, is do you have anything that you could say farmers could do in adapting, for example, their seed choices to mitigate the effects of climate change or to be better equipped to work in the current climate?
Yeah, the thinking of farmers is in some ways quite universal, but then also very cultural as well. And so in South Africa, the bulk of our commercial farmers are pretty large-scale commercial farmers, and they often, not all the time, but they're often quite loyal to a seed company or to a certain sales representative where there's been a good relationship built over years. And so often a farmer will continue planting a variety until it performs very poorly based on, obviously it's got to be successful commercially, but based on a relationship. And that's probably different in every country, I guess. But I think farmers should be testing multiple varieties from multiple companies to see which performs better in their particular environment. Even though the environment might be similar to where a company has bred a certain variety, unless the farmer grows it on his own land and his own management style using the same kind of irrigation and fertilizer and spray programs, they'll never know how it performs until they grow it themselves. And so I think farmers should be doing more testing of wider varieties, if that makes sense. As much as I don't want them to stop planting our seed, but the reality is if they want the best, they'll need to not just take it from the mouth of a sales representative or a product manager, but to grow it themselves, on their own land.
Yeah, it makes total sense. Although if we link it back to what you said earlier, at least for South Africa, Africa is obviously a huge continent with many, many different countries and histories and cultures of farming, maybe it can help to make transparent that, hey, we've tested this through this method or for these localities, so that they can kind of combine their trust in the established relationship with some new information, some awareness of, okay, this is something new that I can incorporate in my place, but it's been tested for this region or it's been tested in a very similar region.
Yeah, I think one thing we've increased the last few years are our breeders visiting farmers. And so often it's our sales representatives or our product specialists that are visiting growers, but more and more as our breeders have been visiting farmers, for the farmer to be able to interact with the breeder and ask questions about the new material that's planted there, that often does increase the knowledge of the farmer. They get an insight as, how the breeding process has happened, what specifically has been selected for or tested for, an example you used. And that's another great way for breeders to see what farmers really want. Sometimes we can't always believe what the salespeople say, but on the other hand, for the farmer to interact directly with the breeder, hugely beneficial for them as well. Yeah.
It's been hugely beneficial for us to have you with us. Unfortunately, time is running out, but I'm very excited that I and also our entire audience got an insight into your work and into Starke Ayres' company. We're excited to keep track of, especially the collab. Maybe you'll be back next season to tell us a little more. Thank you so much, Glennon, for your time.
Pleasure. Thanks, Anna. Appreciate it.
Thank you for listening in today. Want to learn more? Then check out our show notes and more info on computomics.com. If you have questions or want to propose a next guest, please reach out to us at podcast@computomics.com.